So let's look at making summation notation here. And let's use this 6 plus 8 plus 10 plus 12 plus out to plus 32. So we'll use this as a first example for doing this. Okay, and so what we're going to look for is to find a common difference, and we're going to work with that because our goal, remember, is going to be to use that notation where we'll say where we're going to start, where we're going to end, and what the equation will be that will give us each of the terms in here. So what I need to do is think, okay, I'm going from 6 to 8, so I'm going to be plus 2. I'm going to be adding 2 each time here, it looks like. But I'm starting off with a 6, so I have to work with different ways and think about how it is that I could make that. What do I do to 6 to get to 8, but starting with 6, or what kind of thing? And when you think about it and you start playing with it, well, one thing, if I take the number 6, or, well, actually, let me start a little bit earlier. This is the first term. This is the second term. And I'll call it A1, A2, A3, A4, and A to the n right now, because we don't know, how many terms that is. So the first term is 6, the second term is 8. So I'm looking for some kind of relationship that helps me get from term to term and where to start or what to start with. So one of the things here that, let's set this up. Okay. And I want to think, what do I do here? And I can start with a number of different things, but most commonly, I'm going to start with n equals 1. So I'm going to say the first term. The first term is 6. So if n is 1, what do I do to n to make a 6? I can do 6 times n. 6 times n and 6 times 1 does make 6. But when I use the second term and I put a 2 there, 2 times 6 is not going to help me get 8. 2 times 6 is 12. So n times 6 is not going to do it. So I have to think of something else. So when you start playing with it, one thing you can do is 2n. Now, I'm going to do something else with it, but I did that on purpose. Because I want you to get used to this common change as a multiplier times the number of the term. And then think about what else you need. So right now, if I do 2 times the 1, the first term, 2 times 1 for the first term is 2, I would have to add 4 to get to 6. Well, now let's see if that works for the next one. Okay? 2 times the second term makes 4, and 4 plus 4, that is 8, so that works for the second term. Well, let's do it for these next couple and see if it still works. 2 times the number of the term 3, 2 times 3 is 6, plus 4 works. 2 times 4 is 8, plus 4 is 12. It works for each of the 4 terms. So it looks like we found something that can work. Others can work too. There are other ways to do it. But what helps me is using this concept that I can take the common difference and multiply it to the number of the term as my starting point, and then see what else I might need to do. It works in this case, so I have something that I can use. Now, what I'll do is figure out, that's the first term, and then up here, I'm going to have to figure out here what the 32 is. So if 2n plus 4 is equal to 6 for the first term, 2n plus 4 is 8 for the second term, 2n plus 4 is 10 to the third, I can do a little equation here. 2n plus 4 is equal to 32. 2n plus 4 equals 6 gave me 1. 2n plus 4 equals 8 gives me 2. 2n plus 4 equals 32 should give me whatever n is. So 2n equals 28, n is equal to 14, and that's what's going to go up here. That's the 14th term. Okay. So now what this is saying is find the sum, and that's the other part. Remember that this notation, the sigma notation, is telling you, without my having to write here, I don't have to write find the sum. This means find the sum from the first term to the 14th term of the sequence where this is the equation that gives you each number. So, now, I'm not going to go further and find it, because in this part it's just making the summation notation. For 14 terms like that, I could either find out each one and add them all up, which is a lot of work, Or I can use a formula, which in 10, let's see, this one's arithmetic, so in 10.1, 10.2, we go through the formula for getting the sum. So that's what you would use in this case. Now, let's do a different one of these. Where one is? I think I have another. This one was done with numbers, and it makes sense, find the common difference and work with that. Now, let's do it where it's a plus ar plus ar squared plus ar to the, how did I put it? I think I put 14 power. Let's write this in summation notation. Right. Summation notation. So we need to set up the same kind of thing here. We're going to have still an n equals, and it's usually 1, but it doesn't have to be. So I'm going to play with that in this one. We're going to have an ending number of terms, and we're going to have the formula that helps us get each one of the terms. So we have to think about the common difference here, from here to here. Well, I don't have anything, and then I have an r. And then I go to here, and I have an r, and now I have 2 r's, which sort of gives me the hint that to go from here to here, I have to multiply by r. Well, back here, there's no r to multiply by. Well, remember that what that really is ar to the 0 plus ar to the first power plus ar to the second power. That's a useful part of it for you. Because now in this case, we can use the exponent to think of as the number of the term. Because in reality, we can think of this as the first term. We can also think of this one as the first term. So this would be the 0th term. So I'm actually going to think of this one as a to the 0 or a to the 1. Now it's a different a. I really shouldn't use a now. We use a for the amount of the term. Took this from an example I've seen before, and I shouldn't use a in here. But what we'll do is now set it up with this notation. Okay. I see that there's a common difference r. So we have to think about, well, nope, not a common difference. I used the wrong phrase. Because we're multiplying by r here, we're getting a different exponent each time. In the problem up here, we're adding each time, which lends itself to an arithmetic sequence. This one then, because we're multiplying by r each time, and a to the 0 is 1, or r to the 0 is 1, because we're multiplying, that makes it a geometric sequence. This is a linear type of equation or an arithmetic equation. What we need is a geometric equation. And remember that that is the one where it's ar n minus 1. So we're going to need to set this one up in that kind of a format. So if we do think of it this way, well, what we need here is for a to be, well, let's use that 0. Let's say, oh, I want a. I want it to be n equals 0. I'm going to have ar to the nth power. And up here, I want to have it to, oh, already helped me by saying it's 14, so it's going to be 14 terms. I did this one on purpose to take advantage of the exponents, but we could also think of it differently. If you would prefer to have it n equals 1, that would work out fine too. But then that means this would be ar to the n minus 1, because we'd have to put a 1 here. We have to make it so that the first one matches this one, so that it's r to the 0. I can do that by making n equals 0 and an n, or I can do it by making it n minus 1 and making it the first term, but the first term has r to the 0 as the exponent. This, for many people, is preferable because you're used to putting n equals 1. I want you to see this just because it's okay. You know, you can see it, either one are correct, unless you're told to do a certain way. Really, both are correct.
And then it needs to be, for the second one, it's to be 15 on the top, right?
Correct. I actually have that in my notes, and I just realized when you say that, reminds me to do it. And the reason for that is, right now, that's the 0, first, second, third. 0 to 14 is actually 15 terms, because this was 1 and then 2 and up to 14. That's the 15th term. So 0 to 14 is 15. If I do that to 1, you are exactly right. oversight, because I actually have that in my notes, so I know that I meant to do that, but I didn't write it, so thank you for catching it. Because I don't think I would have realized it until later now. But that's another part of it, is that from here to here, even though this says 14, it is a total of 15 terms, so adjusting it is fine as long as I keep it 15 terms. So a very important point for that, to have that correct. All right. So a geometric one, you're really thinking, what are you multiplying by, and then just being careful with how you're starting off with 0, the first power, making sure that whatever you choose, that you can get each one of these terms. So if I say then the first term, that's r to the first, okay? Or was it, the 0th term, the first term, put a 1 here, and that's right. Here, now my first term is the one that has r to the 0. So if I put a 1 in here, I get 0, so I get exactly that. My second term is this one, so n equals 2, 2 minus 1 is 1, I get r to the first power. We're good to go. So either, it would work for both. Going back and checking that is always worthwhile, just mentally seeing, does it actually work? Okay. Now, so that really is the summation notation, using sigma notation, just taking the sequence and recognizing what you need to put here, that you need at the beginning, the ending, and then the equation that you need in order to get each of the terms. And then that's it. Getting the answer would depend upon what the next sections do.